Hi guys, this is Karan this side. So today we'll solve a very interesting question, LeetCode question number 50, power of x raised to n. So in this we have to find the power and we have to find that x raised to the power n. So we have given a double number as the number to which we have to find the int number as their power. So what does the power means? If I say 2 raised to 2, that is 4, 2 raised to 3, that 2 into 2 into 2, 3 times. So that's the power. Now we have to find the power of the double number. Some might say that a very easy question we could just do by, we have a math function also of power x raised to n. But we don't have to use the inbuilt one. We'll do it by bit manipulation. So how we will do using bits? So if we think about firstly of a brute force, in this brute force what we could do, we could just run the loop n times and multiply x into x n times from 1 to n. That was the brute force and will take big of n time. Now, from bit manipulation, we know that if a number is given, the bits of that number is always log, like log 2, or like half the bits. It is log n to the base 2. So what we could do, if I say like 8, its bitwise number will be 1000. So we will consider we will use bits. And how we will use the bits? We will just right shift the bits. If we get 1, we'll just multiply, and in each loop we will double the x. So how we'll do? Firstly we'll take let's take long binom. I'm considering the number as the binom. Why I'm taking it binom? So that we could manipulate it for the bits. If binary number is greater than 0, so what we will do, we will just find out if binary num and 1. So 1, so anything 1 and 1 is always 1, 0 other than they are 0, so it will become true. If it becomes true, we'll take an answer double. Double answer equals to, let's take as 1. So what we'll do, every time multiply it with x. Now in next what we'll do, directly right shift the binary num and we'll multiply x to x, so it gets double and return answer. Now there is missing one thing. I'll tell you what is missing. As we run, positive cases are running fine, but negative aren't. So what we could do to handle the negative cases? So to handle negative cases, what we know that if a number is negative, to make it positive we can take its like 1 upon, like if it is minus, uh, if we have this one, we could just make it 1 upon that number, like any number raised to negative, like for example 2 raised to minus 2 or 3 raised to minus 2 will be nothing but 1 upon 3 raised to positive 2. So to make the power positive, we will just uh, take the input of x as in 1 upon. So we'll just put a if case. If the binary num we are taking binum is less than 0, we will simply uh, make the binary num as positive by just uh, multiplying with the negative sign, and we will just simply take x as 1 upon x. So let's run it and submit. So it is passing all the test cases. So what we have done, we have simply doing a bit manipulation in this. We have taken, we could take n also, we don't have to take binary num separately, but I'm taking it binary num so that it could go to long because integer might get overflowed, because whenever we do negative positive like negative to positive, the last integer int min could can't be converted to positive, it might overflow. So that's why taking long instead of integer n. And then we, what are we doing, we are just shifting the bits of the number. For example, if I have 8, that is 100, so in this first we will see 0 and 1, that is 0, so it won't get answer, won't get any uh, answer, it will be remained 1 only. Similarly, then we are just right shifting, so 1 will be shifted right and it will be out, and will be, the rest will be 100. And in this loop what will happen, x will be multiplied to itself and become double. So if it is 2, it will become, like if it is 8, it will become 8 into 8, 64. Then in the next loop, this 0 will shift again, 64 into 64 it will uh, become. Similarly, but it won't be added into the answer until we get 1, because 1 and 1 is always 1, so it will be stored in answer at that moment only. And this is how we do bit manipulation on the power of x and n. Thank you.